Hey there, Man Math. I hope you guys are having a great day with Mr. Smith. Before I get started on your notes, I want to go over a few things with you that'll make today a lot easier and hopefully help you picture things a little better. We're going to start using all that stuff we learned about absolute value and opposite numbers with our coordinate and our graphs today, and it will all make sense. So, this triangle right here, that guy's our original. That's the first one. That's where we're starting with. And I want you to take a look at the coordinates of all of the points that make up this triangle. So look, these coordinates here, that's 3, 3. This guy over here, 7, 3. And then this guy over here, this is 3, 8. Now look as this triangle is reflected over the y-axis. So just flipped right over the y-axis. But then look at the coordinates here. Oh, this is -3, 3. This is -3, 8. And this is -7, 3. Do you guys notice a pattern there? So that's an example of flipping over the y-axis, where you just take it and go right over the y. And I bet you know what this is. That guy is reflected over the x-axis. So they just took that triangle over the x-axis and flipped it on down. But then look at these points. That point here, I bet you know what this is going to be. That's -3, -3. This point here, that's -7, -3. And this point here, that's going to be -3, -8. So you'll see that the value of the coordinates changes, but the absolute value, that stays the same. So even when we've got -7 and 7, different values, but their distance from the origin, their distance from 0, their absolute value remains the same. So, just wanted to show you what it looks like when something's reflected over the y-axis and reflected over the x-axis. Let's get started on some notes. Alright guys, I want you to go ahead and give Mr. Smith an example of two opposite numbers and explain where those would lie on the number line. What's their distance from 0? Alright, go ahead and pause me while you explain that to him and write it down in this space here. Okay, I hope you paused me. So the example I'm going to give you is I'm just going to do 2 and -2. So there's 0 in the middle of my number line. Bam, 2, bam, -2. Same distance from 0, totally different value. Let's see how that's going to fit in with our graphing. On down we go. So here we're looking at some different points. They look similar, they smell similar, but they're going to be a little bit different. So we're going to start out with 3, 4 and -3, 4. So let's see, we've got 3, 1, 2, 3, 1, 2, 3, 4, and -3, 4. So the similarities, same digits, but their differences, different values. All right. Mr. Smith, you want to pause me for a sec so these guys can get this down before we go on to the next page? All right, let's go. Next page. So now the similarities in location. Well, the similarities in location, they're both going to be on the top half of the graph, right? So in the upper quadrants, quadrants 1 and 4. Upper, can I put upper Q's? Yeah, you guys will know what I'm talking about. Differences in location. One's on the right. So I'm going to say right side, right, versus left. And so the relationship between the coordinates and the location on the coordinate plane, the value of the coordinates determines the quadrant. Value equals quadrant. All right, go ahead and pause this video, and I want you guys to work. All right, did you finish all those? So we're on to our next exercise. So what this is asking you to do is it's giving you a point. It's giving us the point right here on the top. And so you're going to graph that point, and then you're going to graph all of its friends. So it did the first one for you. So S is 5, 3, right here. So 5 over on the X, up 3 on the Y. And then it gave it to us reflected across the X-axis. So boom, down here at M, reflected across the Y, and then the absolute opposite all the way down there. So just like S, we already learned, S is 5, 3. This guy over here, negative 5, 3. A down here, negative 5, negative 3. And M is going to be 5, negative 3. All 4 points have the same digits, but they all have different values. So fill that in. I gave you the coordinates here. So you guys go ahead and fill them in here. And then I want you to practice on these 3. Go ahead and graph those coordinates and then graph all of their friends. So down here, it's asking us when the coordinates of 2 points are xy and negative xy, what line of symmetry do the 2 points share? Well, let's look at our example up here. So here we've got xy, because x and y are both positive, and then we've got negative xy right here. Whoop, sorry guys. Negative xy is right there. So then what we're being asked is what line of symmetry do the points share? So the line of symmetry, across what line are they symmetrical? Across this line, because they're on different sides of this line. Psst, what's that line called? That's right, it's the y-axis. All right, ready for the next page? Let's boogie. So here we have a variation on the same question. So when the coordinates of 2 points are xy and x negative y, what line of symmetry do they share? The x-axis, because they are on different sides of that x-axis. Oops, hold on. Axis. There we go. Alright guys, keep being good for the sub. The exit ticket is already out to you on Edmodo, and the problem set will be homework tonight. Good luck. I'll see you guys later.